All right, so I'm going to continue this journey and now moving a little bit more into open access databases in molecular imaging. And I'm going to show you some places where you can find up to more than 30,000 PET scans. I have no disclosures. So just to, again, set the stage, you've already seen a few different examples of how PET imaging can be used in the field. I'm just showing you a few other examples, how they've looked at the serotonin 5-HT1B receptor in migraine, showing that it's different between normal controls. You've seen it used in cancer research to delineate tumors. More recently, the research has gone into a more psychedelic field. So what you're seeing here is the psychedelic effects of psilocybin, so magic mushrooms acting on the serotonin 2A receptor, which is the main target of this. And then finally, just an example of seasonal differences in brain serotonin transporter of participants that have winter depression. We have that in the northern hemispheres. So just again to set the stage, and as Alessandra also just mentioned, molecular imaging is expensive and it causes exposure of ionizing radiation. Many molecular imaging studies, they have low sample sizes. This directly affects the quality and impact of molecular imaging studies. And then finally, I would try to argue that the solution is data sharing and open access databases to increase the sample sizes. And so just starting from telling you a little bit about the shift towards open science in the field of neuroimaging in general, I would say that 2010 was really one of the years that data sharing broke in neuroimaging, largely headed by this study by Bharat Biswal toward discovery science of human brain function. And this study was a comprehensive mapping of the functional connectome and its subsequent exploitation to discern genetic influences and brain behavior relationship. And they mentioned in this study that it will require multi-center collaborative data sets. So in this study, they initiated this endeavor by gathering resting state fMRI from 1,414 volunteers collected independently at 35 international centers. And what they demonstrated with this was a universal architecture of positive and negative functional connectomes, or connections, sorry, as well as consistent loci of inter-individual variability. Since then, data sharing has become and is becoming the norm in neuroimaging. So just to show you a few examples here of databases that exist, OpenNeuro, Indy for raw data, for statistical maps you can go to NeuroVault and so forth, and for peak coordinates for statistical differences you can go to places like BrainMap and Neurosynth. This is just a quote from an anonymous senior researcher from 2019. OHBM has really been taken over by the open science zealots. One of the tools that are really increasing in the number of data sets that are being deposited is a site named OpenNeuro for sharing raw and processed imaging data. They've teamed up with different parts of the community, so they both share MRI data, they share PET data now, MEG, EEG, and IEG. And since the initiation of this database, since 2018, it has really expanded a lot, and just recently, in late 2023, it also exceeded the 1,000 data sets. On the PET side, or so the PET portal of OpenNeuro, more and more data sets are also being deposited. Right now, there are 165 participants. In fact, there are more, but it's counted as MR data sets because often they both have MR and they have PET. 17 public data sets deposited. And the way that it looks like here is that, again, people or research group, they deposit their data. So this is just an example of a first-in-human evaluation of the radiotracer 11-carbon PS13, which is a COX-1 tracer. And what you see in here is that you have the README just explaining how the data was acquired and where it originates from. You have the authors over here. You have what modalities are available, PET and MRI. And then you have all the data located down here following the bit specification. Furthermore, you also get to see the number of sessions that are available. You get to see the number of participants. It gets a dataset DOI when it's located on OpenNeuro. And what is really nice, I think, is also that the dataset owners publishing this data, they get acknowledgement by having this. So here they can actually, how to acknowledge, you should cite this paper when you're using this dataset. And then also references and links that goes to here, and they're also acknowledging the funding bodies that funded this research. Another recent add-on to this, and this is substantial work mostly carried out by Ariana Sala and others, is work done by the Molecular Connectivity Working Group. And so if you go to their website, they have this resources section here where they've gathered a big list of different data sets that exist in the literature. So here you see some imaging data sets. You see data like the Menage by Shauna Jamada, also located on OpenNeuro. You see the PS13 that I just mentioned, also on OpenNeuro. You see how many subjects are there, the population, healthy controls, or is it the disease subpopulation? You see the age range, the putative marker, COX-1 here, tracer, whether it was a constant infusion bolus, whether it was dynamic or static, all this information is present, including whether external data like T1, T2, so forth were available. It also gives you some information about at what stage this data is available. So you have, for example, non-preprocessed or processed data, so that's the reconstructed data as it comes off the scanner. You have some processed data, so where some initial processing has been done, and also some data where it's directly ready for statistical analysis. You also get some information about the data access, whether it's directly accessible. All the data sets on OpenNeuro are directly accessible, but this is, of course, not always the case. Then just to show you an example so if I'm interested in a certain tracer or a certain receptor system, I could search in here, and I know this database, SIMBI, it's acquired in Copenhagen in Denmark, standing for the Center for Integrated Molecular Brain Imaging. And they have a set of about 1,000 subjects spanning various populations, ranging from healthy controls, MCI, ADD, depression, so forth. 8 ranges, different markers, tracer infusion protocol, and data reconstruction. But the thing is that this data is not openly available. So what you will see here is that the data access, it requires a detailed application. It tells you where you can go and find that application and then apply to get access to this data. If you go to this website, you'll see that, that you have guidelines for SIMBI database applications. You have database application form. And so you can go in here, and then you can fill out this application for access to the SIMBI database, where you want the application's name, position affiliation, and then basically what you want to do with this data. And of course, now it becomes a little bit more tricky because there are different data sharing rules depending on where you are in the world. So this is located in Europe. We are working actively on tools for others to actually access this data, basically making a European platform similar to OpenNeuro. And there is an oral talk about public neuro given by Cyril Pernet at OHBM. So if you're interested in that, you should definitely check out his talk. Just giving you a few practical examples of when sharing data, you can do work like this, work by Justine Hansen at McGill, where she basically was able to work with many different groups that had shared data, both openly and not openly, producing these different maps. And I think this is an excellent use case of data sharing and how we can make these maps that are then useful to both the PET community, but also to other communities of both the MRI and other communities. So to wrap up, together these resources, they include molecular imaging data from over 30,000 participants listed on the molecular imaging website from more than 60 data sets, data for a broad range of biological targets, including perfusion, glucose metabolism, different pre- and postsynaptic neurotransmitters, amyloid and tau pathology and neuroinflammation are currently available. Go check it out. And then I also wanted to mention that while the majority of molecular imaging data are currently not publicly available, funding bodies increasingly require data to be shared openly, so this is something we all need to take into account. And my hope is that the increased availability of open data will make molecular imaging research more inclusive and also produce better research in the future. And then I also just wanted to make this announcement that we are actively working on these databases and to make the information more available and also make it more easy to share this data. So if you're interested in joining some of these efforts, I encourage you to go to the Molecular Imaging Working Group website where you can go into how to join, and you can fill out this form and say that you're interested in, for example, setting up and maintenance of searchable databases of PET studies, data sets, or tools. And with that, thank you for your attention. Any questions?
Hi, Martin. Alexander Hammers, King's College London. Fantastic initiatives, and please keep going. But there are crucial omissions. For example, most people here in the room will be interested in molecular imaging and modeling, but I couldn't find any information on which of these studies have ATIL input functions available. And ideally, one would also want to know whether it's just the final ATIL input function or the constituent parts of the ATIL input function, so you could do your own modeling. So just a suggestion to please also add that. Yeah, thanks.
Right. Thank you so much for that. I wanted to mention that all the data on OpenNeuro, at least, it follows the bit specification. Blood data is defined there, and it's the raw data that's being deposited there. So all the Cox data that I just showed, and Granville will also touch on it later, that has raw blood data. So you can do all the blood modeling and subsequent pharmacokinetic modeling as well. But it's a great point. Thank you. Oh, one more question, maybe?
Hi, thanks. So I was wondering how, if they're from different, I guess the studies they use different. Like one uses one is FDG, the other something else. Can you combine them very easily?
Like you mean between systems, or
when you have I think the idea is to have all these data sets online so that people can combine them to do a better analysis. Mm-hmm. But if they're of different types, like, are they so easy to combine? Do you have to do something else?
Yeah, you need to put them somewhere and do some sort of joint analysis.
So how do you do that, I guess?
So for example, I can say, I'm based currently in Copenhagen, and we have, again, these data sets that are in the SIMBI database. So I've been looking quite a bit on the serotonin transporter. They've acquired that many different places in the world. So I've established data sharing initiatives with them. They either process the data locally and send me the outputs of that, or they send me the raw data, and I do all the processing in Copenhagen, thereby getting larger sample sizes. But the tricky thing is that it depends so much on where you are and what kind of resources that you have available. But
I'm saying if you're comparing different modalities, or not modalities, but different types, then do you have to adjust for that somehow? Or,
when you say types, do you mean
isotopes, for instance?
You mean isotopes?
Yeah.
Sure, it's different systems you look at. I was more thinking of, if you have the same tracer, different sites, you can combine them. Of course, they're from different scanners, so you have to take that into account as well.
Sure.
But that's a whole other issue.
Thanks.
Yeah, thank you for that question.
So Martin, could we say that it's not like you can merge everything together? You need to check if the characteristics of the scanners, the reconstruction protocols and everything are more or less comparable, right? Right, and that's, again, it's a whole other discussion that we can dig into because it's different from site to site. What scanner do you have available? It impacts the resolution. What kind of protocol did you do to acquire this? Sometimes it's static, sometimes it's dynamic. And you can discuss how much you can merge this data. From a statistical point, you can try to take it into account by including that information later, but
or you can try to standardize it in the pre-processing stages. But it's the same issues that we're dealing with as for the fMRI community. How do you actually combine data from different sites? Okay.
Okay, perfect. Thanks a lot.
We have break now?